This video is going to work through question 13 from the review exercises. So our problem says suppose x has an exponential distribution with theta equal to 4. So what that means is that f of x is equal to 1/4 e to the minus x over 4 for values of x from 0 up to infinity. And then we're letting the random variable y equal x plus 1 squared. So we want to find the support of y. So first of all, since x can take values from 0 to infinity, if I think about y, then sort of y is going to be able to take values from 0 plus 1 squared, right? It's going to be less than y. This would be less than infinity plus 1 squared. So when we're thinking about our support of y, y is going to take values that are less than infinity and are greater than 1. So there's our support. Now B asks us to find the cumulative distribution function of y. To find the cumulative distribution of y, which we're going to call g of y, that is the probability that y is less than or equal to the value little y. And we know that y is equal to x plus 1 squared. So if I do a little manipulation here, and say, okay, well that's the probability that x plus 1 is less than or equal to the square root of y, which is the probability that x is less than or equal to the square root of y minus 1. Now I have my exponential distribution, and I can use that to find the probability that x takes a value less than a value by integrating. So this is going to be the integral from the smallest possible value of x, which is 0, up to this value, the square root of y minus 1, of my f of x, 1/4 e to the minus x over 4 dx. And so if I go through and do my integration, what I find is that my cumulative distribution of y, capital G of y, is equal to 1 minus e to the minus square root of y minus 1 over 4. So there's my cumulative distribution function of y. So using the distribution function technique to find that. So now C asks me to find the probability density function of y. So remember the probability density function, little g of y, is the first derivative of my cumulative distribution function of y. So taking my first derivative, this gives me e to the minus square root of y minus 1 over 4 divided by 8 over the square root of y. So there is my probability density function. And then if I want to find the probability that y is greater than 2, I think the easiest way to do it is to use the cumulative distribution function and realize that the probability that y is greater than 2 is 1 minus the probability that y is less than or equal to 2, which is 1 minus g of 2, which is 1 minus e to the minus square root of 2 minus 1 over 4, which comes out to be about 0.9016. And that is question 13.